All right, everybody. Let's move on to chapter 14, section 6, homework assignments. Fortunately, there's only 4 homework problems here. Yay! All right, let's look at the first question. Find the equation of the tangent line and normal lines at the point P sub 0, 3, 3, 2 on the surface of x squared plus 3y squared plus 4z squared equals 52. All right, so let's first look what this thing is talking about. This is 14.6. All right, so it's asking for the equation of a tangent plane. The tangent plane at a point P sub 0, x sub 0, y sub 0, z sub 0 on the level surface of our function equals c of a differentiable function f. In other words, it's got derivatives, it's continuous at every point on the domain. Is the plane through the point P sub 0 and normal to the del of f at that point? So remember, the del of f function was the partial with respect to x, and then the partial of f with respect to y. And if there is one, there's third dimension partial with respect to z. All right, so that is what we're talking about in the tangent of the plane. The formula for the tangent plane to our function at P sub 0 is this. The partial of f at x at the point P sub 0, x minus original x, plus the partial of our function with respect to y at P sub 0 times y minus y sub 0, plus the partial with respect to z at our point P sub 0, z minus 0, set that equal to 0. All right, so our steps are pretty much this. First, find the partial derivatives, partial of f of x, partial of y, partial of f, z if needed. Plug in x sub 0, y sub 0, and z sub 0 from our point. Solve. Moving all constant terms to the other side. All right. So that's to find the tangent plane. Now, to find the equations for the normal line at p sub 0, x equals x sub 0 plus a partial f of x at the point p sub 0, t, y is equal to y, initial y, plus the partial of f with y at the point p sub 0, t, and then z equals z sub 0 plus the partial of f and z at the point p sub 0, t. Remember, the normal line of the surface, or at the surface, at p sub 0 is the line through our point p sub 0 parallel to the delta at p sub 0. All right, so that's pretty much what we're gonna have to do with all four of these. So let's look at question number 1. Find the equation of the tangent for the tangent plane and the normal line at the point p sub 0 on the surface of x squared. So let's look at that. This is 14.6, number 1. So we have our function is x squared plus 3y squared plus 4z squared equals 52. Through the point 3, 3, 2. So it's the tangent and the normal. All right, so for the first part, we have to find the tangent line, our tangent plane. So with that, the first thing we have to do is find the partials. I'll just use these for the partials. The partial of this function with respect to x, 2x, that's 0, that's 0, that's 0. The partial with respect to y, that's 0, that's 6x. And partial with respect to z is 8, it's not, it's y. And then 8z. So that's the first part. The second part, at our point p sub 0, so 3, 3, 2. So x is 3, so we have 2 times 3 equals 6. Y is 3, so it equals 6 times 3 is 18. And z is 2, so equals 16. Now we have our partials, we have our points. Now the tangent plane. We plug them in this equation. C minus 0. So partial x is 6. The x sub 0 is 3. Partial of y is 18. Y sub 0 is 3. F z is 16. Z minus 2. Distribute to get rid of the parentheses. Because remember, we have to have all the x, y's, and z's on one side and the numbers on the other side. So 6 times x, 6x minus 18 plus 18y. Positive times negative is negative. 18 times 3 is 54 plus 16z. Positive, negative is negative. 16 times 2 is 32. So we have 6x plus 18y plus 16z. Now we move the constant terms to the other side. So we'll have 18 plus 54 plus 32. 6x plus 18y plus 16z. 18 plus 32 is 50. 50 plus 54 is 104. Let's see. So it says here, using the coefficient of 3 for x. So we need to have that as 3. So we have to divide everybody by 2 in this whole equation. 6 divided by 2 is 3x. 18 divided by 2 is 9. 16 divided by 2 is 8. And half of 104 is 52. So there's our equation for the normal plane. I mean, I don't, but tangent plane. So that's 3x plus 9y plus 8z equals 52. Now we got to figure out the normal line. So this is the second part. Remember, the normal line, we use these equations. And then z equals z sub 0 plus f of z. Right. So our initial x sub 0 is 3. Our partial of f x is 6 t. That's the first one. The initial of y is 3. Remember, this is x sub 0, y sub 0, z sub 0. F of y is 18. That's our second one. And z is 2 plus 16t. So those are our 3 solutions that go in these boxes. 3 plus 6t, 3 plus 18t, 2 plus 16t. I'm going to do the same thing for number 2. Number two, where our function of the surface is 8z minus x squared equals 0. And we'll find the tangent plane and the normal line. So the first thing we have to do is find the partials. So the partial with x is negative 2x. Partial y, there's no y's. Partial of z is just 8. At our point 8, 0, 8. So at 8, 0, 8, x, so we have negative 2 times 8 is negative 16. That one's 0, and that one's 8. And the tangent plane is the partial of x, x minus x sub 0, partial of y, y minus y sub 0, partial of z, z minus z sub 0 equals 0. Now we start plugging in. So it's negative 16, x minus 8, 0, y minus 0, and 8, z minus 8. Now distribute, get rid of the parentheses. So we have negative 16x. Negative and negative is a positive. 16 times 8, 48, 128. 0 times anything is 0. 8z minus 64. So we have negative 16x plus 0y plus 8z. I like to use, the question is going to ask us for 3 boxes, and this tells me what goes in there. We have 128 minus 64. So it becomes negative 128 plus 64. Becomes negative 64. Now let's see what conditions a coefficient of 2 for x. So we have to have a positive 2 here. So that means you have to divide everybody by negative 8. I hate dividing by negatives. Since that's a negative, that means I change everybody's sign. So it becomes a positive. That becomes a negative. And that becomes a positive. Now we divide by 8. So 16 divided by 8 is 2x. 8 divided by 8 is 1. 64 divided by 8 is 8. Okay, now, since we only have 2 terms here, we have 2x minus c equals 8. We'll move everybody over, make it equal to 0. I mean, you could put both of those in, but for some reason, whenever you have two letters, you'll want to bring the number over. I think because the way they have their system set up on the computers is that it's looking for 3 solutions. All right, so let's plug in these things. So our answer is, for this first part, we have 2x minus z minus 8 equals 0. Now we're going to find the equations of the normal lines. So we have x equals x sub 0 partial of x t partial of y, y sub 0 plus partial of y times t, z sub 0 partial at z t. X sub 0 is 8. The partial f at x is negative 16 t. So there's the first one. 0 plus 0t. So there's the second. 8 plus 8t. And there's the third. So for t, it's 8 minus 16t, 0 for the y, and 8 plus 8t. All right, that's the second. Let's look at the third one. It's asking for the same things: tangent plane, normal line, this function at the point 0, 1, 0. So our function x plus y plus z equals 1 through the point 0, 1, 0. So the first part, to find the tangent plane, we have to find the partials. Partial with respect to x is 1, the rest goes 0, y is 1, and z is 1. So at the point 0, 1, 0, since they're all constant, they stay the same. So it becomes f of x, x minus x0, f of y, y minus y0, f of z, c minus 0 equals 0. That's 1, x minus 0, 1, y minus 1, 1, c minus 0. That's x minus 0 plus y minus 1 plus c minus 0. So it's x plus y plus z, nothing, so it goes over there, equals 1. So there's our first answer. Using a coefficient of 1. So since it equals 0 here, then we got to move it over. X plus y plus z minus 1 equals 0. Because they have it equals 0 here. So it's x plus y plus z minus 1. Now the normals. normals. X sub 0 plus f at x plus t, or times t. Y is y sub 0 plus partial of f to y t, c sub 0 x sub 0 is 0 plus 1t, which is x equals t. Y sub 0 is 1 plus 1 times t is 1 plus t. Z 0 plus 1t is z equals t. So it's t 1 plus t t. All right. And now the last one, number 4. Find the equation for the plane that is tangent to the given surface at the point. Equation of plane z equals radical y minus x at 1, 2, 1. Find the equation of the tangent plane to the surface at the point 1, 2, 1 with a coefficient of 1. So question number 4. It gives us z equals y minus x at 1, 2, 1. Now, we're not dealing with a function here. Z is not the function of with respect to y. We're dealing with this 3 dimensions. So this is the x sub 0, y sub 0, and z sub 0. So we have to move either this one over there or that. So let's move that, because it has to be a function xyz. Now the first thing we got to do is find the partials. So this will take, because we have a radical here. So remember, radical y minus x is the same thing as y minus x to the power 1/2. So the derivative of this, we have to use the power rule, or the chain rule, is, let's say that equals x. So the derivative of x is bring the power down, subtract 1, you get negative 1/2, times the derivative of x on the inside, which is negative 1. So that equals negative 1 over 2 radical y minus x. Do the same thing for y. So the derivative of y, bring that down, subtract 1. Now the derivative of y is positive 1. So this one is 1 over 2 y minus x. And the partial of z is negative 1. So we did the partials. Now we have to find the values at 1, 2, 1. Y is 2 minus 1. So it's negative 1. 2 minus 1 is 1 squared. So it's 1/2. Negative 1/2. 2 minus 1 equals positive 1 over 2. And this is a constant, so it's -1. So now we could plug it into our function. Since we're looking for the tangent plane, we have this formula. So partial of fx is -1/2. X minus x sub 0 is 1. Partial of f with y is +1/2. 1 minus 2. And f at z is -1. C minus 1. So it's -1/2 x plus 1/2 plus 1/2 y. 1/2 times 2 is 1, so -1, minus c plus 1 equals 0. So we know those cancel automatically. And it also said we want a coefficient of 1. So we want a coefficient of x will be 1. For some reason, they always do that. So that means we have to multiply this by -2. Since the coefficient of x is -1/2, we have to make it positive and get rid of the denominator. So multiply everybody by -2. -2 times 1/2 is -1 minus y plus 2z equals 0. So we have x minus y plus 2z equals 0. Yeah, because they have it equal 0. And that's our answer. That's the tangent plane. So it's x minus y plus 2z minus 1. That goes in that box. All right. I hope I helped everybody. Good luck.